All right, today we're going to continue chapter 6 and we're going to start on 6.2, Introduction to Proportion. So proportion, what is that? Well, it's a statement that equates two ratios or rates. So we saw those last time. And they must have the same units in the numerator and denominator for both ratios in a proportion to work. So if we had miles per gallon here, we have to have miles per gallon here. We can't have miles per gallon here and kilometers per gallon here. So it has to be the same units in both proportion and both ratios to make the proportion work. Okay. And what we have here is two rates, and what we're going to do is we're going to call this the first, this the second, this the third, and this the fourth. And so then that way when we get down here to this next part, we can see what those are. And so this is what it looks like in the vertical form, A over B, C over D. But if we lay it on kind of the side, we have A slash B, still A divided by B equals C divided by D. And that's how it's written in line. Then what we have is we can see that these are the inner terms and these are our outer terms. So then when we look at these both either way, we can see we can find extremes and we can find means. Now the first and fourth term, that's the A and the D, that's there and there, those are called the extremes. And if you look at here, those are also the outer two terms. So their extremes are the outer of the proportion. Now the other two, the B and the C, the second and third, those terms are called the means or the inner of the proportion. And so they're kind of the means, which is kind of the middle, and so are the inner, and that's why we have that. And this is just kind of the terminology, but really what's going to come down to is we're going to use the cross product for proportions. And the cross product of the means is equal to the cross product or the product of the extremes. So basically if we take the two extremes and multiply them together, those are equal to the two means multiplied together. Okay. And so what we're going to do is we're going to take A times D, and then we're going to say that's equal to C times B, or A times D is equal to B times C. And that's how we're going to work this. We're going to do the cross product, and that's how we're going to solve problems. The first ones we're going to look at are just to see are they true proportions, and after that we're going to actually solve where they give us a variable in our proportion. Maybe they give us a number A and B and C, but D is a variable. We have to solve for that. Or maybe A is the variable and we have to solve for it. And so that's how we're going to start using the cross product to actually help us solve equations or proportions. So first off, which are true proportions? Well, the only way to really decide if these are true proportions is we do our cross product. So we just multiply across. So we're going to take 6 times 21 equals 7 times 18. Well, now you have to take 21 times 6 and see what that is. So that's going to be 6, that's 12, so that's 126. And then if we take 18 times 7, that's going to be 56. 5 and 7 is 12, so that's 126. So yes, that is a true proportion. Okay. Now looking at the next one, I already know that's 1 1/3 and that's 1 1/2. So I'm pretty sure these are not going to be true. So we'll try it anyway. So we'll take 4 times 2, and that's 3 times 3. Well, 4 times 2 is 8. 3 times 3 is 9. Didn't work. So that's not a proportion. So that's not going to work. Okay. What about this one? 4 times 14 equals 7 times 8. Well, 14 times 4 is 1656. So 56 equals, well, 7 times 8 is 56. So yes, that's back to a true proportion. All right, so that's what we have there. So that's how we make sure it is one. And so, when we're solving proportions later, we can always plug it back in and we can get our value out to see, is this a true proportion or not? So this is where we start working with the variables. And again, it's nothing different. What happens is when we do a cross product, we'll get one thing multiplied and set it equal to something else. And if you think about that, when we get something set equal and we have a variable, we're just going to solve for that variable. And we know how to do that. So 16 times 20 equals 5 times x. Okay. Now before I multiply this out, I'm going to go ahead and divide by 5 here. And you'll see why here in a second. Because when you cancel those, however we want to do that, cancel there, we just get x over here, which is what we want to solve for. Now here, 5 will go into here once, 5 will go in here 4 times. Now I've got a lot smaller thing to multiply, and then I also don't have to divide. So then I just have to take 16 times 4, that's going to be 24, and that's going to give me 64. So then that is my solution to this proportion and solving for x. Okay. Now, what about the next one? Well, if we do that cross product again, all that's going to happen is we're going to have a product of 3 times this whole binomial, and then 12 and 5, and we're going to work it basically the same way we work any equation that we need to solve. And so let's go ahead and multiply here. 4x plus 8 equals 12 times 5. Well, if I multiply here first, then I'm going to have bigger numbers to work with, because then I'll have, 12 times 15, and I'll have a 3 times 8 and 3 times 4. So let's go ahead and divide by 3 first, just to get rid of that 3 out front. So 4x plus 8 equals, now 3 will go into here 1 time, 3 will go in here 4 times. Now I just have 15 times 4 to worry about. Well, that's 20, and that's 60. So that's going to be equal to 60. So that's a lot easier to work with than 12 times 15 and then all these other things. So now let's subtract our 8. Okay, well those cancel. We get 4x equals, well, if we need to borrow here, so that's going to be 52. Okay. Now we divide by 4. And so this one we have to actually do our long division. So that goes in there once. That's a 4. Subtract, we get 1. Bring down the 2. 4 in there goes 3. That's 12. Subtract, we get 0. So then this one says x is equal to 13. Okay. So then 4 times 13 plus 8, all divided by 12, is the same ratio as 5 to 3. Okay. Let's check that though. Okay, so I checked that because I thought something looked astray. Because if we take 4 times 13, that's going to give me a big number. And I realized what I did. That's a 5. I put a 15. I don't know why that was the case, but let's go ahead and erase this one and start over. And hopefully this time we can write down the right numbers and we can get the values what we need here. So, and we erase that. Okay, so now let's write the right numbers down. And that was supposed to be equal to 12 times 5. And so now when we divide that by 3, that goes in once, that goes in 4. Now we have 4x plus 8 equals 4 times 5, which is 20. Now we subtract 8. All right, now 4x is equal to 12 divided by 4. X is equal to 3. Now that seems like a better number. So 4 times 3 is 12 plus 8 is 20 all over 12. And that is supposed to be 5 over 3. So 3 times 20 is 60. 5 times 12 is 60. So the cross product works. And so that looks good. So that's one where when I plugged it back in, that didn't seem right. And that's because I had wrote down the wrong number initially. So you really have to pay attention to what you're doing here. All right, so if 2 watermelons cost $3.89, what will be the cost for 11 watermelons? Round to the nearest penny. Well, so we have to set up our own proportion here. And so I'm going to say $3.89 for 2 watermelons, I'll just abbreviate it W, is equal to, now we want to know the cost here, so that's X, we don't know what that is, and it's going to be for 11 watermelon, okay? Now, all we have to do is do a cross product. and then divide, and we want it to nearest penny, so we'll have to go out to 3 decimal places. So we're going to take 3.89 times 11 equals 2 and then times x. Okay, so that's pretty easy. So now we just divide by 2 and we divide by 2. And so x equals, well, now we actually have to do the math. So I'm going to take 3.89 times 11. So that's going to be 9 and 8, a 3, a 9 and 8 and a 3. And I'll add those. And so we have a 9, we have a 7, we have 8 and 4 is 12, and then we have a 4. Move it over 1, 2 decimal places. Now we'll take 4279 divided by 2, because now we're going to divide by 2, put a decimal here, so it's a 2, and that's going to be 4. Subtract that off, that's 0, bring down a 2. 2 goes into there one time, that's 2. Subtract that off, it's 0. Bring down our 7 now. Well, 3 will go in there, 6, and we subtract that, we get 1. Bring down our 9. Well, 2 times 9 will give us 18. Subtract that off, we get 1. Now we have to do our third decimal place and do that, and that's going to be a 5. That's 10. Subtract that off, we get 0. And so now we've got it to the thousandth, so then we can round to the hundredth, which is the penny. And so then that x is equal to $21.40. And that's going to be how much it is for 11 watermelons. So it's going to be 21.40 for 11 watermelon is equal to 3.89 for 2 watermelon. Now the key here is when we multiply these back, it's not going to be exact because we did that rounding right there. And so if we went ahead and put the 395 at this point and multiplied, then they would be equal. But because we rounded, they're going to be off just a little bit, but that's going to be our cost right there. Okay. All right, so here we go. As proposed, the Shell Wind Energy Project consists of 25 ridgetop turbines that can generate up to 50 megawatts, or enough to supply electricity to about 1,000 homes. Estimate the number of ridgetop turbines needed to supply electricity to 70,000 homes, and then how much electricity is actually generated for those 70,000 homes. Okay, so we're going to have to come up with 2 proportions, it sounds like. One for the number of homes, one for the number of megawatts. And so what we need to do is if we need to find out first how many turbines need to be supply 1,000 homes, we need to set this up as, well, 25, or actually 70,000. We know how many the 1,000 is 1,000. How many is going to be 70,000? Okay, so we have, that's our megawatts, and that's our homes, that's our megawatts, and that's our, not megawatts, those are turbines. We're not to the megawatts one yet. So that's the turbines, homes. And so when we cross product, it's going to be turbines times homes and turbines times homes, and then we're going to solve for x. And so our cross product is going to be 25 times 70,000 equals 1,000x. Well, that's pretty easy. If we divide by 1,000, well, 1,000 will go into here once, it'll go in here 70 times. So x is going to be just 25 times 70. So it's going to be 0, 35, 14, 15, 16, 17. And so that's going to give us 1750 turbines. Okay, so that's how many turbines we're going to need to have for 70,000 homes. Now we can put the other way. We can say, okay, well, now we have 25 ridgetops, gives us 50 megawatts. How many megawatts does 1,750 turbines give us? So we'll have 25, there we go, turbines for 50 megawatts equals, now we have 1,750 turbines is going to give us X megawatts. Okay, so we just did our turbines, how many megawatts it did here. So that's a 50, and then 1750 over X. And so what we have to do is we have to take 25 times X equals 50 times 1750. So we divide by 25, we divide by 25, so those cancel. Well, here 25 goes in here once and it goes in here twice. So X is just going to be 1750 times 2. So that's going to be 0. Then we're going to have 10. That's going to be 15. That's going to be 3. So it's going to give us 3,500 megawatts of power to those 1,750 turbines. Okay, so that's how much they can produce. And that's how much the 70,000 homes needs to be able to have the electricity. All right, so that's all I have for this one, and I'll make another video for the example problems.